This is the first part of the lecture that's going to cover section 6.3 in your book. Our section on 6.3 still talks about factoring, but it's going to talk about special binomials that factor. I'm going to skip some of the meat and potatoes and some of the explanation that I would give if I were standing in front of the class and showing some of the whys behind it. So I'm going to show you the how today, and if you're ever curious about the why, feel free to come by my office and we can sit down and talk through why some of these formulas work. Our first special binomial is what's called a difference of two squares. We call it a difference because it's two terms subtracted, and it's squares because we have two perfect squares that are being subtracted. Something that looks like a squared minus b squared. Now, we need a little bit more room there. When we factor this special binomial, notice that there's only two terms in it. It's going to factor much like our trinomials that we factored on Wednesday. It's still going to look like a binomial times a binomial. Now, the issue that we run into is that first thing is you have to recognize that that is the special situation that we have a difference of two squares on our page. And then you're going to get to remember and know how to use the formula to break it down and to get it factored. Okay. Just because something has two pieces and has a minus sign behind it doesn't mean that it's a difference of two squares. Something like the binomial 2x minus 4, even though 4 can be thought of as a square, there's no perfect square here with this first term. Still, the first thing you should always look for when you're factoring anything is you should look for that greatest common factor. And with 2x minus 4, that greatest common factor is 2. So from there we can pull the 2 out, and we're left with x minus 2 for the other piece. And this is not one of our special binomials. It's not a case that looks like the formula given above. The types of things that we will see that will follow that pattern are things like x squared minus 9. Anytime you notice that you have an x squared or a y squared or an even exponent at all, x to the fourth, y to the fourth, then think about these formulas that we're going to go over today and see if it matches one of those patterns. So I notice the squared on the x, and then the second thing I notice is that 9 is also a perfect square. 9 is the number 3 squared. So if I have x squared minus 3 squared, I now have that form of a squared minus b squared. And so from the formula above, every place there's an a in the formula, I'm going to put an x, and every place there's a b in the formula, I'm going to put a 3. So this will factor x minus 3 times x plus 3. If you wanted to check, FOIL that back out on the right, combine your like terms, you're going to find out that we get the x squared minus 9 that we started with. Maybe I have y squared minus 25. Again, I notice the even exponent there, that I have a squared y term, and I also recognize that 25 is 5 squared. So I now have a squared minus b squared, and so again, every place there's an a in the formula, I'm going to put a y, and every place there's a b, I'm going to put a 5. The only difference between the two expressions after you have the binomial factored is that one will have a plus sign and one will have a minus sign in between those two, in between the two terms. Maybe I have 4x squared minus 49. Again, if I notice numbers like 2's and 9's and 16's and 25's and 49's, I'm going to think about squares. And most of you will be more successful if you take the time to write this step down that I've written on the two above, the x squared minus 3 squared step and the y squared minus 5 squared step. If we look at 4x squared is just 2x, that quantity, squared. 49 is the number 7 squared. Once I've written this step down, I can see that here's my a, squared minus b squared. So every place there's an a up above in the formula, I'm going to put a 2x. Every place there's a b in the formula, I'm going to put a 7. Again, if you FOIL that out, you should be able to double check and verify that that's the way that 4x squared minus 49 factors. Again, with the x squared minus 9, a lot of you will get to the point where you can just look at it and recognize that it factors x minus 3 and x plus 3. But with some of these others that get a little bit bigger in their numbers, or maybe the variables are not just 2 powers of 2, a lot of you will benefit more, and do better on your homework if you write that intermediate step in. So if we have 25y to the 4th minus, let's say, 16z to the 6th, I notice that my exponents are all even, meaning I can write them as something squared. I also notice the 25 and the 16 there, and since they're perfect squares, I try to see if I can pick apart the expression and write it as something squared minus something squared. When we think about what gets squared to get 25, 5 is the number. 5 squared is 25. Now if I'm wanting to square a power of y to get y to the 4th, since a power to a power means we multiply exponents, I have to think 2 times what will get me 4. So if we square the 5, we get 25. If we square y squared, we get y to the 4th. Moving over to the 16z to the 6th, 16 can be written as 4 squared. Z to the 6th, I take 2 times 3 to get 6. So if I square z cubed, that's what's going to get me to z to the 6th power. Okay. So I need these up here, these have to be squareds for me to use my formula. So then I get to come up with what is a, what do I square in each expression there to get back to those values that we started with at the beginning. Once I've broken it down and say this squared minus that squared, then we can factor. We know we take a minus b times a plus b. And we're done. What I'd like for you to do in your notes now is go ahead, I'm going to put one on the board, pause for a couple seconds, so you can pause the video and work through it at your desk, and then replay or push play again on the video when you're done, and compare your answer to mine. See if you've gotten the right thing. All right. So let's look at 9 x to the 4th minus 16 y squared. Hopefully you paused the video and tried this one by yourself before you just kept listening to me. But if we break 9 x to the 4th down, we're going to square 3 to get 9, square x squared to get x to the 4th. 16 is 4 squared, and y squared is plain old y squared. So in our formula at the top, every place there's an a, we'll put 3x squared, and every place there's a b, we'll put 4y. That means this expression will factor 3x squared minus 4y and 3x squared plus 4y. Okay. I'm going to stop this video here and get it going on the internet, and then this part 2 of this video is going to talk about our cube formulas. Actually, no, before I stop the video, sorry, I want to make one other comment. If there is a plus sign in between your squares instead of a minus sign, okay, a squared plus b squared, that polynomial is going to be prime unless there's a greatest common factor that can be pulled out. So if we have x squared plus 9, that's a prime expression, it's not going to factor. If we have 4x squared plus 4, those are both squares. However, it's not prime because they have a 4 in common. I can pull out that greatest common factor, but then the stuff that's left in there, even though it's still two squares, that plus sign means the rest of that's prime. So a plus sign in between your squares means it's not going to factor unless you can pull a greatest common factor out. With the minus sign in between, a squared minus b squared, I've shown you several examples of those. Hopefully that's enough to get you started on the homework.